Okay, please welcome back to my channel. Today we'll be taking a question from differentiation. He said we should differentiate y is equals to 2x raised to power 2 plus 3x minus 2 with respect to x using first principle. Now the question now is, what is differentiation? What is differentiate? Differentiation simply asks us the rate of change of something. Now we have that y is a function of what? X. We want to see the rate at which y changes with respect to what? Changing what? X. Meaning that for every time that x changes, what will be the new y? What will be the new position for what? Y. Now, we say that for the y dx, which is the rate of change of y with respect to the what? The rate of change of what? X is equal to the limit as change in x approaches what? 0 of what? Change in y over change in x. We are saying that the derivative, the y dx, is equal to the limit as change in x approaches 0 of change in y over what? Change in x. Now let us try to explain this what further. Assuming I have 2 points on a graph, let's consider this coordinate. That P is on the coordinate y, s, y. And we have another point which is on the coordinate s plus change in x. And we have y plus what? Change in y. Let us see how this path comes about. If I have a curve and we have our P here and our Q somewhere here, this is our y-axis, this is our x-axis. We are saying that P is existing on which coordinate? When the horizontal axis is x, that means here is what? Y. And our Q is existing on this coordinate, s plus change in x, and here is what? Y plus change in y. We are not saying that the difference, the rate of change or the change between P and Q, which is from here to here in respect to s, is what? Change in x. Y from here to this place is what? Change in y. We are saying that if this change in x, if we are existing in, or if we are on point Q, if this rate of change in x is approaching 0, when it is approaching 0, that means it's going to be on this part. We are not going to get this derivative. That's what this simply means. Okay, now let us go back to the question to try to differentiate this. So we have a question that says that y is equals to 2x squared plus 3x minus what? 2. We want to see the rate at which y changes with respect to what? Changing x. Now, if we are going to see this, what it means that this is the first position or the initial position. Initial position. Now, let's consider any change at all. Any change at all. So, we are going to use, for any change at all, we are going to say that this is going to be changing y and changing x. If we are going to consider a new position, this would now be y plus change in y is going to be equals to 2 bracket. Anywhere I see x, I will call this x plus what? Change in x. Or raised to power 2 plus 3 x plus what? Change in x minus what? 2. This is the new position we are trying to consider. Now this first one was the original position, but we are saying that we can use this to predict any subsequent value of the new position. So far you give us the value of what? X. I can tell you what will be in y. Now we want to see the rate at which this what changes. Now we are saying that the new position is this. Let's try to expand this. This would now be that y plus change in y is equals to 2. Now this, let us try to expand this bracket. This s plus change in s all raised to the power of 2. This will give us s squared plus s times changing s times 2 will give us 2s changing x plus changing s squared plus 3 bracket s plus what? Changing x minus what? 2. So we can proceed to what? Remove the brackets. Now let's try to remove the bracket. We'll now be having that y plus change in x, sorry, this is change in y, is equals to, we remove the brackets. So for us to remove the bracket, that means we are going to multiply everything inside the brackets. So what do you mean that 2 times change in s, 2 times s squared is going to give us 2s squared plus 2 times 2s changing s will give us 4s changing x plus 2 changing s squared plus 3x plus 3 changing x minus what? 2. Okay, we'll check if there is any like terms in this place. Do we have any like terms? No. So we can proceed to make, remember that we said that the derivative that we want to solve is if our derivative is equal to the limit as changing s approaching 0 of changing y over changing x. Meaning that we first of all need to make changing y over changing s the subject of the formula. Now we already have our changing y here. We can now take y to the right hand side since we want to make changing y subject of the formula. This would now be that changing y is equals to 2s squared plus 4x changing x plus 2 changing s squared plus 3x plus 3 changing x minus 2 minus y. That means we have taken plus y to the right hand side. When we take plus y to the right hand side, this will give us what? Minus y. Now, but remember that y alone is simply what? This. Y alone is simply 2s squared plus 3s minus what? 2. So we are going to substitute the value of what? Y into this equation. So this becomes that changing y is equals to 2s squared plus 4x changing x plus 2 changing s squared plus 3x plus 3 changing x minus 2 minus bracket. We substitute the value of what? Y. What is y? Y alone is what? 2s squared plus 3s minus 2. So we'll write this as 2s squared plus 3x minus what? 2. Okay, we'll proceed to remove the bracket. This will give us that changing y is equals to 2s squared plus 4x changing x plus 2 changing s squared plus 3x plus 3 changing x minus 2. We'll remove the bracket. So when we remove this bracket, this will give us minus 2s squared minus 3x plus what? 2. So we'll collect like terms. We'll collect like terms. When we collect like terms, we are having 2s squared. Okay, let's rearrange this like this so that it will be clear enough. This will now give us 2s squared. We also have a minus 2s squared here. They are like terms, so this is minus 2s squared. We are having plus 4x changing x plus 2 changing s squared plus 3x. This is also minus what? 3x here plus 3 changing x minus 2 plus what? 2. Okay, so if you notice, 2s squared minus 2s squared is going to give us what? 0. So this is going to be that changing y is equal to, here becomes 0, we now have here to be 4x changing x plus 2 changing x squared. Now plus 3s minus 3s will also give us what? 0. So that place will go off plus 3 changing x minus 2 plus 2 will also give us what? 0. So we now have that changing y is equal to what? 4s changing x plus 2 change x squared plus 3 change x. But don't forget, we said that the derivative, the y dx, is change the y over what? Change the x. So what do? We divide both sides. We try to divide both sides by what? Change x. So I will divide here by change x, and I will also divide here by what? Change x. So we now have here to be changing y over changing x is equals to 4x over changing x, all divided by what? Changing x plus 2 changing x squared over changing x plus 3 changing x over what? Changing x. Okay, so we are just using a division rule to say that this changing x is going to divide the individual terms in the numerator. So we'll be left with changing y over changing x is equals to changing x will cancel one of these changing x, will have 4x plus changing x will divide one of these changing x, will have 2 changing x plus changing x will take out one of these changing x, will have plus what? 3. So we are saying that changing y over changing x is going to be equals to what? 4x plus 2 changing x plus 3. Now, but we are not done. So we said that the y dx is going to be the limit as changing x approaches what? 0. So we are going to take the limit here. We are going to take the limit as changing x approaches what? 0 of changing y over changing x. What does this mean? It means that anywhere I see changing x, I'm going to substitute it to be what? 0. Because we are saying that this changing x is now having a value that is what? 0. This would now be 4x, there is no changing x plus 2 bracket what? 0 plus 3. And this will be equal to what? 4x, 2 times 0 will give us 0 plus 3. Are you seeing this? So we are not saying that the y dx is equals to the limit as changing x approaches 0 of changing y over changing x, which is now equals to what? 4x plus what? 3. Which is now equals to what? 4x plus 3. So when we differentiate this using the first principle, it's going to give us 4x plus 3. Thank you for watching, and please comment, subscribe, and share this video to your loved ones.